We've learned a little bit about pressure now. Now we're going to talk about manometers, which are a tool that is used to measure pressure, but they can also help us understand how um, hydrostatic pressure works in more complex situations. So let's look at our manometer over here, which has this odd little Mickey Mouse thing here. What's happening here? Well, we're trying to measure the pressure in our balloon here. So we're going to assume that that pressure is higher than atmospheric pressure. Um, and what we can do is think about the pressure in this tube is going to be constant as we're moving horizontally here. And we can compare it to the pressure outside by using a manometer. Let's work through this in a hydrostatic way and see what the difference in pressure between point 4 here is and point 1. So at point 1, we know that the pressure is atmospheric pressure because when two fluids meet each other and they're not moving, the pressure is the same in both fluids. So we know it's atmospheric pressure out here, so we know that it's atmospheric pressure there. 2 is deeper in our fluid, and so we know that the pressure is going to be higher there. Our gauge pressure is going to be higher. The gauge pressure here is 0. Down here, it will be 0 plus rho P, or I'm sorry, rho GH. Okay. So we can write this down here. The pressure at 2 is equal to the pressure at 1 plus the change in pressure between 1 and 2. The pressure at 3 is the same as 2. Why? Because they're even horizontally, right? Even though this is an odd shape, as long as the fluids are connected, any place where, if you're in a static tube, any place in that is horizontally level will have the same pressure. So 2 is equal to 3. And then what's the difference between 3 and 4? Well, between 4 and here, there's no difference in pressure. Between here and here, there is a difference in pressure. And that difference in pressure is rho air times H times G. Okay, so we can write pressure in 4 is the pressure in 2 minus the pressure change here, right? Because it's going to be higher pressure at your lower spot and lower pressure up here. And then if we replace P2 with what we had before, we end up with this equation. And we can write this. So this is just an algebraic rearrangement of our first equation. So pressure at 4 is equal to the pressure at 1 plus the pressure gain here minus the pressure loss here. Now the key thing is the difference between these, right? P liquid, or a rho liquid, is going to be much larger than rho air. And in fact, it's so much larger, usually on the order of magnitude of about 1,000 times, that we can ignore this rho air. It's going to give us a pretty small error when we take it out. And so we can rewrite this as our manometer equation. Where the gauge pressure right here is going to be Hg rho. It's basically the pressure difference here. You can see that, right? Because the pressure in here is pushing the water down, okay? The force is strong enough that it can lift this water here. And that's why we get this equation here. Now we know pressure has the units of force and area, but you may have noticed that blood pressure and in fact atmospheric pressure are sometimes measured in length, right? So if you look at a blood pressure gauge, you'll notice that the units are in milligrams mercury. I'm sorry, not milligrams, millimeters mercury. The way a blood pressure gauge works is that you apply pressure through the little squeegee tube, right? You apply pressure to the arm with the arm wrap, and enough pressure to shut off blood flow, and then you lower it until you can hear that blood flowing again. The magnitude of pressure is measured where the technician can hear that flow again, and it's measured in the height of the mercury that is held up by that pressure. In other words, the H is the same H that we talked about in the previous equation, which is Hg rho. And so rho here is the density of mercury, which is going to be constant. G is a constant. And so we use that H as a shorthand for the difference in pressure between the blood pressure and the atmospheric pressure. And you can see the same thing when you look at atmospheric pressure. If you listen to the weather report, you'll hear things like, oh, the pressure is 29.9 inches. And it's the same process, except they're measuring inches mercury.